Hello, good morning once again. You're welcome to the second chemistry tutorial class for Alpha Tutors, the best tutorial online. So it's still our 1 month free tutorial, and you are very welcome once again to the class. So we are just going to start. So today we'll be make sure to like and subscribe the video always, so that you would make sure when you subscribe you turn on the notification bells that I can also always see our video when we post them. Okay. So let's get into it. Today we'll be dealing with particulate matter, nature of matter, and laws of chemical reaction. Fantastic topic. You know, last time we talked about the nature of matter, we talked about the changes, we talked about the different kinds of changes, we talked about elements, compound, and mixtures, and we also talked about how to separate mixtures, the different techniques, the principles, the uses. I also gave you some assignments to check out like the differences between element and compound, differences between metals and non-metals, the two tests for purity and all that. I hope you have all done that. So today we'll be looking at the particulate nature of matter and the laws of chemical reaction. We mentioned in the last class that matter is made up of discrete particles, which includes atoms, molecules, and ions. And today we are going to focus on those three things because these are the things that relate with one another for there to be reaction, for chemical reaction to take place. So in any material that you see, in any matter, when I mean material, I mean matter, anything that has mass and that can occupy space, is always contained either of atoms, molecules, or ions. Okay, so we'll go one by one on these things. So what's an atom? The ancient Greek were the first to use the word atom, and they believe that when you slice something and slice it and continue slicing until you can slice no more the smallest part of a substance, that's the atom. So the atom is defined as the smallest particle of an element which can take part in a chemical reaction. And a better definition is that it's the smallest part of an element that can ever exist and still possess the chemical properties of that element. So we talked about elements in our last class. So we can have an oxygen atom, an hydrogen atom, nitrogen atom, and so on and so forth. So if we understand that atom is the smallest part of an element, then we can move to the next form, which is molecules. What are molecules? So most atoms can't exist alone. And this is the important difference between molecules and atoms, is that molecules, most atoms can't exist alone. So molecules may be made up of atoms of the same element or of different elements, but molecule is the smallest substance that can exist alone. That's the definition. And also it's the smallest particle that can normally exist alone and still retain the chemical properties of that compound, or of that substance rather, be it an element or a compound. So for example, how do we separate atom from a molecule then? So for an atom, is the smallest part of an element that can take part in the smallest part of an element that can ever exist and still possess the chemical properties of that element, or can take part in a chemical reaction. Great. But the difference is that oxygen atom is O, right? Let me show that with this. Coming? Good. So this oxygen atom, O. But this oxygen atom cannot exist alone. It exists normally as O what? O2. Good. So this is the oxygen molecule containing two atoms of oxygen, while this is the oxygen atom. There are some other elements that, let's say for example, helium. Helium exists as helium atom, He, right? And as molecule too, He. So this is both helium atom and helium molecule. That's the difference. Difference is in whether the substance can exist alone. So molecules is the smallest particle that can normally exist alone and still retain the chemical properties of that substance, be it an element or a compound. So I already gave the example of O2 as an element, oxygen molecule, and a compound like ammonium chloride, NH4Cl. In our last class, we talked about it, as one of the substances that can sublimation from solid directly to gas, or from gas directly to solid. Maybe I didn't mention it. Sublimation is actually solid directly to gas or gas directly back to solid. Good. So we have done the definition of atom and molecule now, and we have seen the differences between them. So the number of atoms in each molecule is called atomicity. I already gave example of helium. Helium is monoatomic because you require only one atom of helium in the molecule. The atomic is like oxygen. This is oxygen atom, but for it to be a molecule, you require two oxygen atoms. So it's diatomic. Triatomic molecules, for example, ozone, O3, which requires three atoms of oxygen. Then polyatomic, requiring more than three. For example, phosphorus requires 4, and sulfur requires 8. Good, let's move on. I need to undo these annotations. Okay, good, amazing. So, let's move on. So what are ions? Ions are the third thing. So we have said matter can either be composed of atoms, molecules, and ions. Ions is an atom or group of atoms that possess an electric charge. That's the most important thing for you to know. So first assignment today, ladies and gentlemen, students, Jamb students of the Alpha tutors that are going to do very well in the exam, is that you're supposed to learn Dalton atomic theory. So John Dalton actually proposed some atomic theory, which can be summarized into about 5 of them, and they have been modified. So what I want you to do is to go and learn those theories and the modifications, because they're important in the laws of chemical reaction we're going to see. So let's move on to formula of elements and compounds. So we already know what an element is. We defined it in our last class. We already know what a compound is. This is an example of a compound. Calcium thiazocarbonate 4 is a compound because it's you having more than one element in a substance. This calcium hydroxide, OH2. And then we also have radicals. All right. So the radical there is the OH minus, right? So I already defined a radical as any group of this is a radical, something like this. If you see this OH minus, this is a radical. It always goes like this. The other ones like NH4 plus. All right. You know, this is a Jamb tutorial class, so I believe that you know most of these things I'm talking about. NH4 plus. So this is the ammonium radical ion. So let's move on. So I'm giving you other examples of compounds like hydrogen chloride, HCl, compound of 2 elements, hydrogen and chlorine, H2O, water, that's compound of hydrogen and oxygen, NH3, ammonia, nitrogen and hydrogen, and this is calcium hydroxide. All right. So if we're good, we can move ahead. So it's just good to also mention here that, you know, in thinking about the particles and the size of a molecule, you know, it has been estimated from the oil film experiment to be n times 10 raised by minus 7. That means it is very small. And this is centimeter. This is centimeter, right? Same. So that means it is very small. Centimeter. It is very small. Where n is between 0 and 10. So like 2 times 10 is per minus 7 centimeter. So the next thing to look at is to look at the relative atomic masses of substances and the mass spectrometer. So the mass spectrometer is just an equipment used to measure, okay? This is the most accurate instrument in measuring the masses of compounds, and you can also differentiate like between isotopes of the same elements and all that stuff. So to get masses of isotopes, molecules, compounds, we use the mass spectrometer. So the relative atomic mass is just means an atom of an element. How much does it weigh? That's just a simple explanation. You know, there's a more complex definition that defines it as the relative atomic mass is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. But that's just a fancy thing. Let's just know the relative atomic mass is, I need to cancel these annotations because they're obstructing our view. All right, amazing. So we have undone everything now. All right, so that's relative atomic mass. Relative molecular mass is the sum of all the relative atomic masses of all the atoms in one molecule of that substance. So it's like the same. If relative atomic mass is the atomic, let's just say the mass of one atom, one single atom, and you know that for hydrogen it is 1, for carbon it is 12, oxygen is 16, thereabout, sodium is 23, chlorine is 35.5, potassium is 39, calcium is 40. So for relative molecular mass, it's just the sum of all the relative atomic mass. So let's solve this. Calculate the relative RMM means relative molecular mass of limestone. Limestone's formula is calcium CaCO3. So this is very, very easy. If you see all these kind of questions, you shouldn't miss them, right? So calcium is 40, that'll be 40. You're just going to add up. So these are the relative atomic masses of these elements. So you add up 40, right? Plus carbon is 12, plus 12, then plus oxygen in 3 places. That's plus 3 times 16. I wish I could be faster. 3 times 16. So if you add this all together, you will get the relative molecular mass of the substance. 3 times 16 is 48. 48 plus 12 is 60. 60 plus 40 is 100. So the answer is what? 100. So the relative molecular mass of that substance, in this case, limestone, calcium triazocarbonate 4, is 100. We're good. So that's how to calculate relative molecular mass. So I have to undo this too, so that it doesn't disturb our screen. So you can go ahead and calculate for the hydroxide ion, OH minus, and see what you will get, okay? This is O16 and H is 1. All right, so let's move. So if you're enjoying this video, make sure to subscribe and like the video so that others can also see it. And you make sure to turn on notification. So let's talk about the mole concept now, because this is also important. So the mole is just a measurement way. So it's important to know that, we already mentioned there's a constant called the Avogadro's constant. By now you should know it. It's 6.02 times 10 raised to the power 23 is a constant. And for every mole of every substance, it contains this amount of particles. So 1 mole of hydrogen atom contains 6.02 times 10 raised to the power 23 hydrogen atoms. Okay? 1 mole of anything contains 6.02 times 10 raised to the power 23. That's the important thing to note. All right, so let's do some more calculations. What is the mass? First one is, what is the mass of 3 moles of oxygen gas, O2? So 3 moles of, you need to separate oxygen gas from oxygen atom. In our first class, we mentioned that mixture, the air is a mixture of different gases, including oxygen gas. Oxygen gas is O2. It is not O. O is oxygen atom. Oxygen gas, which is a molecule, is O2. It exists freely as O2. To calculate the mass of 3 moles of oxygen, let me bring in my stuff again. So 3 moles. So the thing in front of all these things are the moles or the molar volume. So 3O2, where the relative atomic mass of oxygen is 16. So that would be 3, into brackets. We'll now do 2 multiplied by 16. Sorry, 2 multiplied by 16. 2 multiplied by 16 is 32. 32 times 3 is 96. So that'll be 96 grams. That's the mass of 3 moles of oxygen gas. That's quite easy. That's quite easy, right? So let me undo this. So I can do the second. The second one says how many atoms are there in 6 grams of carbon? They're supposed to give us here. The question is not complete. That the relative atomic mass of carbon is what? 12. So let's assume the question is not complete. 12 grams, right? So that's the important thing about listening and understanding, so that you'll be able to apply. In our first class, I told us the important thing about science is not just in knowing, it's in being able to apply. So C is equal to 12 grams. So they're asking how many atoms are there in 6 grams. And we said earlier on, you remember, let me even go back to it, that 1 gram contains, 1 gram contains, sorry, I said 1 mole of every substance contains 6.02 times 10 raised to the power 23. We said it here. So they're asking for the number of atoms. You already know that 1 gram of carbon contains 6.02, 1 mole of carbon, and 1 mole is exactly equals to 12 grams. So this is just a mathematical problem that you can solve on your own. If 12 grams will give you 6.02 times 10 to the power 23, 6 grams will be what? Half of that. So you just divide 6.02 times 10 to the power 23 divided by 2, and you get your answers. All right? Great. So let me undo this. The next question is, how many moles are there? This is there in 20 grams of calcium triisocarbonate. We already calculated the relative molecular mass to be 100 grams. So 1 mole of this is equals to, so this is another mathematical question. 1 mole is equals to 100 grams, right? Is equals to 100 grams. Or let's say 100 grams is equals to, equals to 1 mole, because that's what they're asking. So they say how many moles are there in 20 grams? So if 100 grams is all right, so we'll just continue. So I was saying that here we can do we're in number 3. So we can do how many moles are there in 20 grams of calcium carbonate? So I was saying that 1 mole 100, we already know the relative molecular mass is 100. So 100 grams, okay, 100 grams will give you what? 1 mole. In fact, let me use the typing instrument. Okay. So the way to solve this is this. You already know that 100 grams would give you what? 1 mole. So it's just maths. 1 gram, if you divide both sides by 100, it will be equals to 1 all over 100 mole. So if you divide both sides here by 100, to give you this one, 100 over 100 give you 1 gram. 1 over 100 here. So 20 grams will be equals to what? Equals to 1 all over 100 multiplied by 20. 20 here 1, 20 here 5. This will be 1 over 5. So equals to 1 over 5 mole or 0.2 mole. So that's it basically. That is it basically there. So next question is calculate the percentage mass. This is another mass question again. Calculate the percentage mass of all the component elements in sodium triisonitrate 5, which is NaNO3. So you first of all calculate the relative molecular mass of sodium triisonitrate. Sodium is 23 plus nitrogen is 14, that's 37, plus 3 times 16, that's 48. 48 plus 37, that's 85, right? So if you have to calculate percentage mass of 23 sodium, that'll be 23 over the total 85 times 100 over 1. For nitrogen, it'll be 14 over 85 times 100 over 1. For oxygen has 3 here. So it'll be 3 times 16, that's 48 over 45 over 85, the total times 100 over 1. So that's it basically. That is it basically. Let's move on. So the percentage masses that we just calculated with this question is important in calculating the empirical and molecular formula of any substance. And it is important that we know that the empirical formula is the simplest formula of that substance or that compound, while the molecular formula is the definite formula. The example I gave you is ethyne and benzene. So ethyne, the formula for ethyne, which is an alkyne, is CH, right? The real formula is what? CH. While the formula for benzene is C6H6. Sorry, H6. If you divide the smallest ratio between, if you divide both sides by C, this will be CH. So the empirical formula for benzene is CH. The molecular formula is C6H6. The empirical formula for ethyne is CH. The molecular formula is CH. So the empirical formula is the simplest formula if you divide both sides into the lowest units. So you see, ethyne and benzene, they have the same empirical formula, but different molecular formula. So we can use this to calculate, empirical formulas and to help us. So let's do this. They said find the empirical formula of the compound, which an analysis is the following as the reactive masses: carbon 2 gram, hydrogen 0.34 gram, oxygen 2.67 gram. Then from your results, find the molecular formula of the compound if its relative molecular mass is 60. So how do you go about this now? They already gave you the reacting masses. So all you need to do is to divide. So in calculating the empirical formula, which is what we are on now, is just to divide the reacting mass over the atomic mass. So let's write carbon here. There are 3 elements here: carbon, hydrogen, and oxygen, right? Good. So for this one to be 2, the reacting mass of carbon here is what? Is 2, as you can see here. 2 all over the atomic mass, which is 12. Sorry, I thought I was writing 2. I wrote the 2 here. Excuse me. Good. So 2 all over 12. Great. We'll do the same for hydrogen. The reacting mass is 0.34. 0.34 all over relative atomic mass 1. For oxygen, that will be what? 2.67 all over 16. Great. So you divide this out, what will you get? This will be 0.17. This will be about 2. And this will be about 0.17 also. So in calculating empirical formula, what you now do next is to divide these figures that you have gotten now by the smallest number in this 3, which is 0.17. So if you divide this by 0.17 to give you 1, you divide this by 0.17 to give you, you'll get about, if you divide 2 by 0.17, you get about 2. And if you divide this by 0.17 also, you get 1. So the empirical formula is C1H2O1. But because we don't write 1, it's just CH2O. Sorry, O. The 2 is downwards, okay? So this is the empirical formula. The next is calculate the molecular formula if the RMM is 60. So we already know the empirical formula. We just write equals to 60 grams. So to now know the real molecular formula, we now write CH2O into brackets, because as you said, there'll be something that will multiply everything. And there'll be X here. X is what we are looking for. Equals to 60. Good. So we already know we can now calculate the masses here using this one that we're given. C is 12. H times 2. That's 1 times 2, 2. So 12 plus 2, 14. Plus oxygen, 16. That is 30. So 30x equals to 60. So if you divide both sides by 30, that means x will give you 2. So that means x is 2. So the empirical formula is CH2O. But if you don't want to get the molecular formula, you multiply everything inside the bracket by the x we have gotten now, which is 2. So that means the molecular formula will now become what? C2H. Multiply these 2 now by the 2 outside, 2 times 2 be 4. Then 4 times 2 be 2. So this is how to differentiate between empirical formula and molecular formula. Help you understand. We can use either the reacting masses or the percentage by mass. We calculated percentage by mass here using sodium, this, divided by the relative atomic mass. So yeah, I would like you to try questions on your own on getting the empirical formula and the molecular formula. The next thing to talk about is the valency. The valency of elements and of radicals. In the valency of this radical now, ammonium ion is +1. So you check the sign beside the radical. For OH, it is 1, 2. Here it is 1. Here it is also 1. So it's not about the sign, it's about the number. Here it is 1. This is CO3, 2 minus. 2 minus is on top here. So this is 2. Okay. I want you to check out these assignments. These are very, very important assignments. It's connected to your first assignments on checking out Dalton theory. So you have to relate Dalton theory to understanding the 4 laws of chemical combination. The law of conservation of mass, the law of definite proportion, law of multiple proportions, and law of reciprocal proportions. I want you to go and check this out. That's the second assignment to understand the different laws. In fact, in your quiz, there are questions on this exactly. So please check it out and know it for your own benefit. We all know how to balance equations, I believe. There's one n here, there's one n here. There's 3h here, there's 2h here. So automatically you have to put 2 here, so that 2 times 3h will be 6. And you put 3 here, so that will be 6 also. So, since I put 2 here, you also have to put 2 here. But this is not balanced because there are 3 oxygen, 2 oxygen now. Anyways, I don't want to convince us. Let us just also know how to balance equations. The element on the reactant side must be the same as the element on the product side. The way to balance this now is to, there'll be a 4 here, 4 NH3. So 4 times 3 hydrogen, that's 12. Can put a 6 here also. 6 times 2 hydrogen, that's 12. Then there's 6 oxygen here, plus, because you have put 4N here, you have to also put 4 here. So 4 oxygen plus 6 oxygen, that's 10. You have to put a 5 here. So please learn how to balance equations also. The third assignment, I've given you 2 assignments now. Dalton theory, understand the 4 laws of chemical combination that are related to Dalton theory. So the third thing I want to check out is what are the importance of chemical equations. There's some importance attached to chemical equations. Like, for example, it tells us the individual elements and radicals involved, in the chemical reaction. So there are about 6 information provided by chemical equations. And there are 3 informations that are not provided, like the speed of the reaction, the colors of the reactant and the product, and the heat changes during the reaction. So I want you to check out the 6 importance of equation. Okay, I just gave this as, okay, see this question. Calculate the number of moles of oxygen, this is oxygen, required to heat 6 moles of water. So from this equation, you can easily just see that you need 1 mole of oxygen, of O2, to give you what? To give you 2 moles of water. So if you want to find how many moles of oxygen, you need to give you 6 moles of water. If you multiply both sides by 3, 2 times 3 will be 6. So 2 times 3 here will be equals to 6. Then the other side too, 1 times 3, 1 multiplied by 3. So you need 3 mole of oxygen to give you 6 moles of water. That's just an easy peasy thing. So In summary, ladies and gentlemen, today we've spoken about what an atom is, what a molecule is, what an ion is, and they are the three things that uh, um, that represent or constitute what matter is. Matter is. We've also spoken about relative atomic masses and the use of mass spectrometer. We've also spoken about relative molecular mass and how to calculate it using the relative atomic mass of the elements in that compound. We also define how to use the empirical formula, how to get the empirical formula either through by dividing the reactive masses by the relative atomic mass. Let me show you guys. Yes, like we did here. The reactive masses were already given us, and then we just divide it by the relative atomic mass. If they don't give you the reactive mass, but they give you, you know this one, percentage by mass, like we did here. Can also use this percentage masses over the relative atomic masses too. So we talked about that. I don't want us to check up on the laws of chemical combinations. They are very easy. The first one is the law of conservation of mass that states that matter is neither created nor destroyed during a chemical reaction, but changes from one form to another. There are three models for you to check out. So that's basically it. Thank you so much for watching. Make sure to click like and subscribe and do the exercise after this video is in the description box. Do the exercise. I promise it's going to challenge you and you're going to learn a lot. So next week, guys, when we do chemistry again, have a wonderful time.